Calculus is the study of rate of change. So derivative at a point or slope of tangent line at a point or instantaneous rate of change at a point are all the same things. So if we have a function f of x, the function f of x is given with 2 points a and b on it. 2 points a and b. Point A and point B are given on it. The coordinates of point A are x1, y1. Coordinates of point B are x2, y2. So if I were to find the slope of the secant line, the secant line is the line passing through, the secant line is the line that's touching the curve at 2 points. So if I'm finding the slope of secant line is the yellow line. I want to find the slope of this yellow line. So all I have to do is the slope formula, which is difference in y coordinates divided by difference in x coordinates. That slope of secant line is called average rate of change, which is m. M is the letter used for the slope. M secant, or the slope of the secant line, can be written as y2 minus y1 over x2 minus x1. Now, y2 can be also written as f of x2 minus f of x1 because f of x is same thing as y. So the y value at point x2 minus the y value at point x1 divided by the difference in the x coordinates. So difference in the y coordinates divided by difference in x coordinates. What if we want to find the instantaneous rate of change at point C? Or what if you want to find out instantaneous rate of change at point B only? What if you want to find out instantaneous rate of change? To find instantaneous rate of change, we need to find the slope of the tangent line. Tangent line is the line that's touching the curve at 1 point only. So tangent line is the one that's touching the curve at 1 point only, and I did not draw the tangent line correctly. Let me fix it. It would be touching the curve 1 point. So that would be the blue line would be the tangent line at point B. Blue line would be the tangent line. What if you want to find out the slope of the tangent line? There's no way to find the slope when you only know 1 point on the curve. So what we're going to do is we're going to bring the point A really close to the point B and then find the slope of the line passing through these 2 points. We're going to say the point A is very close to point B, or x1 is very close to x2. We bring the 2 points infinitesimally close to each other, and then we find the slope, and that's going to be my instantaneous rate of change. And that's very helpful. For example, if I drive from here to Sacramento and I know the distance covered and the time taken, I can find my average rate of change by doing the distance divided by the time. But if I want to find out instantaneous rate of change, so how fast I was going at 30 minutes, or how fast I was going when I was 20 minutes after I started. So that's when we can use the slope of tangent line. We can find the 2 points around that, around the 20 minutes time. We can find the 2 points very close to 20 minutes time, and then use the secant slope formula to find the instantaneous rate of change. Okay, instantaneous rate of change. So definition of derivative at a point x equals a. So if we have a point x equals a, the derivative would be f prime of a equals limit x approaches a, f of x minus f of a over x minus a. Memorize this definition. This is very important. We're going to be using it over and over. We can also use difference quotient to find the derivative. So whenever you're doing the homework, you can use either one of these. You can either use the limit definition, or you can use the difference quotient. Difference quotient f prime of x would be limit h approaches 0, f of x plus h minus f of x over h. Both are exactly same things. Okay, so in the first case, my 2 points are, my point 1 is x comma f of x. Second point is a and f of a. F of x or f of a is just the y value. So x and the corresponding y value at the point A and corresponding y value at the point. So we say x approaches a. We say limit x approaches a. That means x and a are very close to each other. The point x and a are infinitesimally close to each other, and this is just the slope formula. F of x minus f of a, that's y2 minus y1 over x2 minus x1, just the slope formula that we talked about. So we're estimating the instantaneous rate of change by bringing the 2 points very close to each other. In the difference quotient, the same thing. My points are x, f of x, and x plus h, f of x plus h. So I'm using the 2 points x and x plus h. Limit h approaches 0 means that x and x plus h are very, 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 very close to each other, infinitesimally close to each other. So again, this is y2 minus y1. This is my y2 minus y1, difference in the y coordinates divided by difference in the x coordinates. So we would be just able to cancel the x and x, only h will be left. So both are the same things and they both come from the slope formula, and we are finding the slope of the tangent line. That's what this x approaches a or h approaches 0 means, that 2 points are very, very close to each other. Notations for derivative, we use y prime or dy dx or f prime of x. Sometimes you will also see it written as x equals a. Dy dx when x is a, when you're looking for derivative at a particular point. So you might be finding derivative at a particular point. You might be finding derivative, just the general derivative that you can plug in any x value and find the derivative at that point. Here, so I wrote the difference quotient. I'm just evaluating derivative at x equals 1 using two different techniques. The first, I have the difference quotient technique, when f of negative 1 plus h minus f of negative 1 over h. I can either do that, or I can use the definition of derivative, which is limit x approaches negative 1, f of x minus f of negative 1 divided by x minus 1. Both will give me the same answer. Both will help me find the derivative at the particular point. So sometimes your derivative, if you're looking at a graph, the derivative can be 0 in some cases. Derivative of a constant function is 0 because derivative is the rate of change. Derivative is the slope of the tangent line. So if I were to draw a tangent line at this point, let's just say this is point x equals 1, the derivative at this point will be 0 because this line does not have any rise. It does have some run. There is some run. If I draw the tangent line, the red tangent line does not have any rise. It does have some run. It goes left and right but doesn't go up and down. So the derivative is going to be 0. Same thing if we have a constant function. Let's say my function is f of x equals 5. And I'm going to draw f of x equals 5. F of x is the same thing as y. So this is where the 5 is. So I draw this line. What's going to be the derivative of this line? Derivative is the slope of the tangent line. So if I draw a tangent line at any point, the tangent line would be just like this line, and there's no rise for that line either. So slope would be 0. So derivative of a constant function is 0. Derivative of a constant function is 0. Now I'm going to use this definition of derivative, or the limit definition of derivative, or the difference quotient to estimate some derivatives. Let's look at some examples. You can use either one of those. They both will give you the same answers. Okay. And let's look at a couple of examples. Find the equation of tangent line to the graph of f of x equals x squared minus 3x plus 5 and x equals 2. Okay, so to find equation of tangent line or equation of any line, you might recall from algebra, you need a point on the line, x1, y1, and you need the slope of the line, which is m, and then you can use the point slope form, which is y minus y1 equals mx minus x1. Once you know a point on the line, once you know the slope of the line, you can go ahead and plug into point slope form and estimate or find the equation of tangent line. So before we can get to the equation of tangent line, the first thing we need is slope of the tangent line. Slope of tangent line is same thing as derivative. Slope of tangent line is same thing as derivative. So I'm going to look for the derivative in this case, which will be at point x equals to f prime of 2 is limit x approaches 2, f of x minus f of 2. I'm using the difference quotient here. You can use the limit definition of derivative. Both will give you the same thing. F of x minus f of 2 divided by x minus 2. Limit x approaches 2. F of x is x squared minus 3x plus 5 minus f of 2. If I plug in a 2, so that would be 4 minus 6 plus 5 divided by x minus 2. That's 9 minus 6. That's going to be a 3. So limit x approaches 2 x squared minus 3x, 5 minus 3, that would be plus positive 2, x minus 2. If I go ahead and plug the x as 2 in, I get the 0 over 0 form. That means I need to use some algebra techniques, evaluate the limit using some other algebraic techniques. So I can factor the numerator, two numbers that multiply to give me positive 2, add up to give me negative 3 are negative 2 and negative 1. And I can cancel the common factor between numerator and denominator. Good thing my remaining function is continuous at x equals 2, and I can just go ahead and plug the 2 in. So m tangent line slope is equal to 1. Slope of tangent line is equal to 1. Once we have the slope of tangent line, it's really not that big of a problem now, because we know the point slope form. We can just go ahead and plug the points, plug everything into the point slope form. Okay, so let's go ahead and let's go ahead and find the point on the line. So point on the line, we're given the x coordinate is 2. If I plug the 2 back into the f of x, I would be able to find the y coordinate, which is 2 squared minus 3 times 2 plus 5, which is going to be 4 minus 6 plus 5, and that is a 3. Okay, and we already know the slope of the tangent line. So let's plug them into point slope form. This is my x1, y1, y minus y1 equals m, x minus x1, y minus 3 is equal to x minus 2, y is equal to x minus 2 plus 3, y is equal to x plus 1, and that is my equation of the tangent line. That's what we were looking for. Sometimes they might be asking, the problem might be only asking you to find slope of the tangent line, so you would just stop at finding the slope of tangent line, but in this case, we were looking for equation of tangent line, so we finished all the way. Next, we're going to compute f prime of 4 when f of x is 1 over x plus 1. Okay, so f prime of 4, so we can do either, we can use the limit definition of derivative, or we can use a difference quotient. So limit x approaches 4, f of x minus f of 4 divided by x minus 4. If you were to use the definition of derivative, you would be plugging you would be just using a 4 in here. 4 minus h. So 4 plus h. So we'd be using, if you were to use, you would be using limit h goes to 0, f of 4 plus h minus f of 4 divided by h. You could be using the definition of derivative or the difference quotient. Both ways, it's going to give you the same answer. So go ahead and give it a try. Right, f of x minus f of 4. Let's go ahead and plug the values in. Limit x approaches 4, 1 over x plus 1 minus 1 over, if I plug a 4 in there, x minus 4. I'm going to combine the fractions in the numerator. 5 times x plus 1, 5 minus x minus 1 will be my numerator because I have a complex fraction here. So I'm trying to combine these and get it into a single fraction divided by x minus 4. Limit x approaches 4, we would get 5 minus x, that would be 4 minus x, because 5 minus 1 is 4. 4 minus x over 5 times x plus 1 divided by x minus 4. So we can write this as, we are doing 4 minus x over 5 times x plus 1 divided by x minus 4. Limit x approaches 4. 4 minus x can be written as negative x minus 4 times 1 over x minus 4. The x minus 4 was the one that was causing me issues, that was causing me trouble. I could just get rid of the, I could write x minus 4 minus x as, I can cancel the common factor between numerator and denominator now. So I do have a negative in the front, and 1 over the remaining function is continuous at 4. So go ahead and plug a 4 in there. 4 plus 1 is 5. So negative 1 over 25 is the derivative at point 4, or slope of the tangent line, or instantaneous rate of change at point x equals 4. Okay, I also want to show you how to use the limit definition of derivative. So I'm going to erase this and proceed with the limit definition of derivative. That way you know how to do both the techniques. And you can use either when you're doing homework. They both give you the same answer. So I'm going to start by limit h approaches 0 f of 4 plus h minus f of 4 divided by h. So limit h approaches 0, 1 over x will be replaced by 4 plus h, and next time x will be replaced by 4. Limit h approaches 0, 1 over 5 plus h minus 1 over 5 over h. Limit h approaches 0, 5 times 5 plus h, 5 minus h divided by h. So limit h approaches 0, the 5 and negative 5 is gone, negative h over 5 times 5 plus h divided by h. And we can, the 104 is the base number, you can ignore it, negative h divided by 5 times 5 plus h times 1 over h. We can cancel out the common factor between numerator and denominator, and remaining function I can just go ahead and plug as 0 in for h. It leaves me with negative 1 over 5 times 5, which is negative 1 over 25. So you get the same answer whether you use the limit definition of derivative or use the difference quotient to calculate the derivative. Let's see one more example. Compute f prime of 3 when f of x is square root of x plus 2. Alright, so limit x approaches 3, f of 3 minus f of x minus f of 3. F of x minus f of 3 divided by x minus 3. Or you could use, so this is the difference quotient, you could use the limit definition of derivative. Limit definition of derivative says limit h approaches 0, f of 3 plus h minus f of 3 divided by h. Okay, so both are the slope formula, difference in the y coordinates divided by difference in the x coordinates. Let us proceed with the difference quotient. So limit x approaches 3, f of x is square root of x plus 2 minus f of 3 is square root of 5 divided by x minus 3. If I go ahead and plug a 3 in here, I'm going to get a 0 over 0 form, indeterminate form, and that's going to get me in trouble. And I don't want to get the 0 over 0 or indeterminate form. So what I'm going to do now is I will be rationalizing using some algebra techniques. I will rationalize the numerator. Okay. When I FOIL, the numerator leaves me with x plus 2 minus 5 over x minus 3 square root of x plus 2 plus root 5. Okay, close to be done. Limit x approaches 3, x minus 3 over x minus 3 square root of x plus 2 plus root 5. Now at this point I see that x minus 3 was causing me big trouble when x was approaching 3. I was getting a 0 in the numerator and 0 in the denominator, but that factor cancelled and my remaining function is continuous at x equals 3. So we can just go ahead and plug in x is 3. So square root of 5 plus square root of 5, which is 1 over 2 root 5. So we just saw we use the difference quotient to find the derivative at a particular point. We can also use the definition of derivative for the same problem. So I'm going to show you that, and I'll use the green color to write. That way we can distinguish. So we're done. This is my derivative. We could stop here, but if you prefer using the definition of derivative, or if the problem says use the limit definition of derivative, then we would use the limit definition of derivative. Technically, both are the same things. You're really finding the slope of the tangent line by bringing the 2 points extremely close to each other, infinitesimally close to each other. Limit h approaches 0, f of 3 plus h, that would be square root of 5 plus h, minus f of 3 is square root of 5 divided by h. Limit h approaches 0. Again, if I plug h as 0, I get 0 over 0 form, so I have to rationalize. Square root of 5 plus h minus root 5 over h times root 5 plus h plus root 5 over, I'm multiplying numerator and denominator with the conjugate. All right, this is going to leave me with, let's see, my numerator becomes limit h goes to 0, 5 plus h minus 5 over h times square root of 5 plus h plus square root of 5. 5 and negative 5 cancels. Limit h approaches 0, h over h times square root of 5 plus h plus square root of 5. Because I have the common factor in numerator and denominator, that cancels, and the remaining function doesn't care if h becomes 0. It is still defined. So 1 over 2 root 5 is what, this is going to be my derivative at that particular point. One more example we'll look at. Let's see. Right. Here we have differentiate the function using the definition and then find the equation of tangent line at indicated point. Okay, so we want to find the derivative using, we can either use the limit definition of derivative, so we can say limit, this is the point x, limit x approaches 3, f of x minus f of 3 over x minus 3. Limit, either use difference quotient or use the limit definition. If you want, you can use the limit definition of difference quotient. Both are using the definition. That's just, both are the definitions of derivative. So f of x minus f of 3 over x minus 3. That would be f of x is square root 1 plus square root of 4 minus x minus f of 3 would be 1 plus square root of 4 minus 3 is 1 divided by x minus 3, which is limit x approaches 3, 1 plus square root of 4 minus x minus 1 plus 1 is 2 minus 2 over x minus 3. Limit x approaches 3, 1 minus 2 is negative 1, so square root of 4 minus x minus 1 over x minus 3. If I go ahead and plug a 3 in here for the numerator and denominator, I get 0 over 0, and that's not okay. That means I need to use some algebra techniques, so I'm going to rationalize the numerator. X approaches 3, square root of 4 minus x minus 1 over x minus 3 times plus 1 over square root of 4 minus x plus 1. So I'm going to go ahead and distribute the numerators, FOIL, so that will leave me with 4x minus 1 over x minus 3 square root of 4 minus x minus 1. Limit x approaches 3, that would be 4 minus 1 is 3, 3 minus x over x minus 3 square root of 4 minus x minus 1. Okay, 3 minus x is same thing as x minus 3. So instead of writing 3 minus x, I can write x minus 3. Limit x approaches 3. This is going to be x minus 3. And now we have a common factor between numerator and denominator. The remaining function doesn't really care if x approaches 3. It is still defined. So that would be square root of 4 minus 3 minus 1. Square root of 4 minus 3 is square. No, that does not look right. Negative 1/2. Let's see. X minus 3 square root of 4 minus 1 squared plus 1. Oh, there is a plus 1 here. So we multiplied. That was a plus 1. That's why. That was a plus 1. So that would be negative 1 over 2. That is going to be my slope. Slope m is negative 1 over 2. Once we have the slope, finding the equation of line is not that bad. Y minus y1 equals m times x minus x1. So equation of tangent line. Equation of tangent line would be y minus y1. We're given the point x1, y1 in the problem. So I'm going to use the x1 as 3, y1 as 2. Y minus 2 equals m is the slope. It's negative 1/2 x minus 3. Y minus 2, let's go ahead and distribute negative 1/2 x plus 3/2. Finally, if you want to isolate the y, we would add 2 to both sides, negative 1/2 x plus 3/2 plus 2, which would be negative 1/2 x, 7/2 plus 7/2, negative 1/2 x plus 7/2. Yep, that would be a positive 3/2. Add a 2. Yep, perfect. That's the equation of tangent line.